Hey tech learners, welcome back to the channel. In the last previous two lectures, we have seen Cayley-Hamilton theorem, we had seen the statement of the theorem, and we had seen how to verify Cayley-Hamilton theorem for a square matrix. In today's lesson, we will see how to find out the inverse of a matrix using Cayley-Hamilton theorem. To find inverse, we need to multiply this Cayley-Hamilton theorem by A inverse. So once we multiply this by A inverse, this becomes A0 I dot A inverse plus A1 A dot A inverse plus A2 A square dot A inverse plus and so on, and this is AN A to the power A inverse is equal to 0. And as we know, if we multiply any matrix with its identity, then the resultant is the matrix itself. So this will become A0 A inverse plus, and if we multiply a matrix by its inverse, then the resultant is always identity matrix. So this will result in A1I plus, here we will reduce the power. So this will become A2 A dot A dot A inverse. We can write A square as A dot A, and this A dot A inverse in turns will become I. So this will be the identity matrix, and as we know that any matrix multiplied with the identity matrix will give us the matrix itself. So this can be written as A to A plus and so on. Let's say if we write another step, so this would be A3 A square plus and so on, an capital A to the power n minus 1 is equal to 0. Now we'll keep this on the right hand side and then we'll get the A inverse. So now this will become A1I plus A2A plus A3 A square plus and so on, an capital A n minus 1. This is equal to A0 A inverse, and we can bring this A0 back on the left hand side. So this will become whole 1 divided by A0. So here we can see we will be able to evaluate this A inverse using this formula. Now let us see this with the help of an example. In this question, we need to find out the inverse of A, where the matrix A is given in this, using the Cayley-Hamilton theorem. So first we need to write the this characteristic equation, and then we'll apply the Cayley-Hamilton theorem to find the inverse of the given matrix. So just to get the characteristic equation, first we'll write the characteristic matrix of this. So this is 1 minus lambda, 0, 0, 2 minus lambda, and now we'll expand this. So this will become 1 minus lambda multiplied by 2 minus lambda. Now we'll open this. So this will become 2 minus lambda minus of 2 lambda plus lambda square. This equation becomes 2 minus of 3 lambda plus lambda square. So this is the characteristic equation of the given matrix. Now by using the Cayley-Hamilton theorem, as we know that every matrix satisfy its characteristic equation, we will replace the lambda here by the matrix itself. So now we will be able to write this equation again in the form of Cayley-Hamilton theorem. So this will be 2I minus of 3, in place of lambda we will write A, and then plus lambda square. So we need to write A square, and according to the Cayley-Hamilton theorem, this should be equal to 0. Now we will multiply A inverse in this equation. So this is according to the Cayley-Hamilton theorem, and now we will multiply in this equation number 1 by A inverse. So once we multiply, this becomes 2 A inverse minus of 3I plus A is equal to 0, as we have already done into the original equation. So once we multiply I with A inverse, it will give us A inverse. We will multiply A with A inverse, it will get I, and if we multiply A square by A inverse, it will result in A only. So from here we can see that twice of A inverse is equal to 3 times of I minus of A, from which we can see that A inverse is equal to 1 upon 2 3 times of I minus of A. Now we just need to replace the identity matrix and the matrix itself in this equation to obtain A inverse of the given matrix. So now let us replace this matrix here and just write the identity matrix for the given matrix just to obtain the inverse of the matrix. So here we can see that A inverse is equal to 1 upon 2 inside the brackets. This is 3 times I. What is I? 1 0 0 1, and then we have minus of A. So A is 1 0 0 2, and this is 1 by 2 outside. So now we will solve this. So this will become 1 upon 2, and the matrix would be, you can see this is 3 into 1, that is 3, 3 minus 1, which is 2, 3 into 0, that is 0, 0 minus 0, which is 0, 3 into 0, that is 0, and minus 0, which is again 0, 3 into 1, that is 1, minus of 2 will be a minus of 1. So you can see this is the A inverse of the given matrix. So here we have used Cayley-Hamilton theorem to find the inverse of a given matrix.